Compound A contains carbon, fluorine, and chlorine atoms. The vapor density of compound A is 25 degrees Celsius and 100 kPa, is 6.895 grams per liter. What is the molar mass of compound A? Okay, your takeaway from this question, what I want you to learn from this one is you do not have to know every single formula. You do not have to know everything before you go into an exam. You can figure it out along the way. Okay? I've actually given you the equation for density before, but it's not something we deal with very commonly, which is fine. You can figure it out as you're going. So let's have a look at A. They gave you the density, and it's 6.895 grams per liter. Guys, you can figure out you can figure out the equation by looking at the units that they've given you. Yeah. Whatever density is equal to, the units of it are grams per liter. Grams per liter is grams divided by liter. Yeah. Guys, what variable is grams? Is grams moles? Is grams volume? Is grams concentration? Grams is what? Grams is mass. Okay. And what letter do you use for mass? I'm going to represent it in the equation for you. M. All right. And then grams per liter is grams divided by liter. So mass divided by whatever. And then liters is what? Liters is volume. And then what letter do you guys use for volume? V. Okay, you don't have to know every single equation before you go in. You can figure it out based on the units. Density is 6.845 grams per liter, which is equal to mass divided by volume. So like now, if you go into the exam and you want to have it memorized, go ahead. I'm just saying you don't have to. Yeah. Now, there's a bunch of different equations going on here, which is okay. We're going to figure out how to combine them as we're going. Guys, 25 degrees Celsius and 100 kPa is temperature and pressure, and it's a gas. What's the equation for a gas that has temperature and pressure inside of it? You can just give me the name if you don't remember the equation. It's the ideal gas equation, which is PV is equal to nRT. Gay-Lussac is one of them. I think it's pressure and temperature as well, but I want all of them together because I'm going to have to combine volume and moles and stuff later. So the most general equation for a gas is the ideal gas equation. PV is nRT. Okay, and then last thing is the molar mass. What is the formula for molar mass? Oh, sorry, what is the formula that has molar mass in it? We'll rearrange it after. There's only one equation that has molar mass in it. Yeah, it's the moles is mass on molar mass equation. Good. Moles is mass on molar mass. So then molar mass is equal to mass on moles when you rearrange it. Okay? So I've interpreted all of the information in the question. They've given me numbers for density, which is the first equation. They've given me pressure and temperature, which is the second equation. And I need molar mass, which is the third equation. Yeah. If I'm going to use all of the numbers from the question and solve for them together, I need to relate all of those different variables together. Yeah. Otherwise, I'm jumping from one equation to the next, which is a lot of work. It might just be easier for me to combine them into one. Okay. And then you're like, how the heck am I supposed to combine it into one? Where am I supposed to sub it into? Do I sub all of them into the density equation? What do I do? You figure out what variables to sub in or out based on what they want. Okay. Guys, they've given you density, they've given you temperature, they've given you pressure, but what they really, really want is molar mass. Okay, that's what they want. Yeah. What that means is, guys, when you're trying to figure out how to sub these equations into each other, the one thing that you have to include is this. Yeah. However, we're going to sub these equations and put them together, I cannot lose mass and I cannot lose moles. That's it. Okay, I cannot lose mass and I cannot lose moles. Yeah? You can lose whatever you don't have a number for. Okay? Because if you try to keep that in your equation, you're just not going to have anything there. Yeah? You're just not going to have anything there. So I need to keep mass on moles. because that'll be molar mass. So let me keep this. Let me keep this. I need to keep density because I have a number for that, 6.845. And I need to keep temperature because they gave me a number for that. I need to keep pressure because they gave me a number for that. I'm going to keep R because there's a number for that from my data sheet. I can't lose R if I wanted to, guys. I don't have anything to sub it in. Yeah. So the only thing left, and then remember, I need to keep mass because that's mass on molar mass. I need to keep moles. Okay. The only variable that I don't have a number for that can be subbed out is volume. Okay. So guys, I'm going to rearrange this equation. Density is mass on volume. So therefore, volume is equal to mass on density. Okay? I figure out what to keep in or sub out based on what numbers I do or don't have. I'm going to get rid of my volume because I don't have a number for it. I can't sub in anything for it anyway. Yeah? So PV is equal to nRT. I've rearranged my density equation. Volume is mass on density. So now I'm going to sub it in as that. P instead of V, mass on density. And that'll get rid of my V. You see that? Yeah? Is equal to nRT. Okay? I don't have a number for volume. I can't sub anything in for it anyway, so I'm going to get rid of it. Yeah? I'm just going to clean up this equation. I'm going to multiply the density over, guys, just so I don't have a denominator and I can get rid of the fraction. It's just easier to look at. Yeah? So now I've got mass and moles in the same equation. What I really, really want is mass on molar mass. Okay, because that's what they asked me for. They want molar mass, which is mass on moles. So guys, currently mass is on the left-hand side of my equation, moles is on the right. I'm gonna divide my moles over to the left so I can get mass on moles. And then I'm gonna divide my pressure over to the right. Okay? So then I can leave mass on moles alone. So then on the right-hand side, I'll get RT times density divided by P. Yeah? Now I've got molar mass, because molar mass is mass on moles. I'm going to sub in RT, density, and P. And notice that RT, density, and P are all variables that I have numbers for. Yeah? R is your ideal gas constant, which you can find on the data sheet. It's 8.314 joules per mole per Kelvin. And then who remembers, guys, for your ideal gas equation, what unit do you have to have temperature subbed in as? Because it's currently given to you in Celsius. You need to sub it in kelvins. How do I convert Celsius to kelvins? Plus what? What do I plus?
273, I think.
273.15. Yes, good. So I'm going to take the 25 and then I do plus 273.15 kelvins. And then the density was given to me. That was 6.895 grams per liter. 6.895 grams per liter. And then divide by pressure, which is, what did they give it to me as? 100 kPa. Okay. So your kelvins cancel out. Your joules will cancel out with liters and kPa. There are specific units for those. I know they physically don't cancel out on your paper, but that's because joules has different units. Yeah, so joules, whatever the other units are, joules is PAM3, and then it's also kPa liters. That's why it cancels out. Yeah. So then the only thing you'll get left with are grams per mole, which is molar mass. Okay. What do you get when you sub this into the equation? Carefully, 8.314 multiplied by, in brackets, 25 plus 273, multiplied by 6.895 divided by 100 kPa.
170.9.
Thank you. 170.9 grams per mole. Okay, so that is your part A. So what you learn from this question is how to rearrange different equations together to get what you want. Okay, cancel out anything that you don't have a number for. Yeah? And then you also learn from this question how to figure out an equation based on the units, grams per liter is mass over volume. Yeah? Part B, chlorofluorocarbons, such as compound A. Compound A is what this question's about, yeah? So the very first sentence before part A said that compound A contains carbon, fluorine, and chlorine. So part B, chlorofluorocarbons, such as that compound A, can react with sodium metal to convert all of the chlorine present into sodium chloride. Guys, 100 mils of gaseous compound A is reacted with sodium at 25 degrees Celsius and 100 kPa. The products of the reaction are dissolved in water and a few drops of sodium chromate solution is added. The resulting solution is then titrated with 0.3540 molar silver nitrate solution until a bright red precipitate appears after 22.79 mils of the titrant has been added. How many chlorine atoms are present in a molecule of compound A? What syllabus dot point is this question about? It's module 8. Don't say module 8 because I asked if they said module 8. I was like, no bloody way it's module 8. All right. What syllabus dot point, not what module? Good. It's a precipitation titrations question. Okay, guys. So they talk to you about titrants, and then it's not an acid-base titration because no acid base mentioned. There's a bunch of different ionic compounds mentioned. And also they said a bright red precipitate. Yeah, this is a precipitation titrations question. However, they haven't asked you for something about the titration though. So again, this is another one of those questions where I really need you to pay attention and understand what's going on. Otherwise, the calculation is not going to make sense. Okay. What they are asking you for is how many chlorine atoms are present in a molecule of compound A. Now, guys, compound A actually did not participate in the titration. Yeah, I need you to see what's going on, okay? The very first sentence in part B gives you a bit of context, all right? What did they say? Compound A reacts with sodium to convert all of the chlorine present into sodium chloride. Okay? And then the second paragraph is where the question actually starts. Compound A gets reacted with sodium. The products are dissolved in water and then titrated. Okay, so compound A gets reacted with sodium first. Whatever that turns into then goes into the titration. Okay, so guys, the question is asking you how many chlorines are in compound A. You're not going to get that from the titration. Okay, so you're going to interpret your titration data first and then jump back to the chlorine after, jump back to the compound A after. Yeah. Now, what they are asking you for is the number of chlorines in compound A. So guys, if they're asking you for chlorines in compound A and they give you titration data to do that, and compound A doesn't show up in the titration, it has to relate to the chlorine somehow. Yeah, otherwise there's too many disconnects. Okay, so compound A reacts with sodium. All of the chlorine, guys, all of the chlorine present gets converted into sodium chloride. Okay, that's the product of the reaction. Okay, the products of the reaction get titrated. All right, so what that tells me is this, guys, I'm going to deal with my titration data. That's going to give me information about sodium chloride. Okay, that's not going to give me information about chlorine itself. However, guys, all of the chlorine present gets converted into sodium chloride. Yeah? So I'm going to get the amount of sodium chloride and that will tell me the amount of chlorine. Okay? So keep that in mind. I'm going to deal with my titration now. We'll get to sodium chloride and then we'll talk about compound A again. Okay? All right. So I know that the product of the reaction is sodium chloride. That's what goes into the titration. And then the titration is with the silver nitrate. So that's what I'm going to write my equation for. So NaCl, aqueous, plus silver nitrate, AgNO3, aqueous. When you're dealing with ionic compounds, the ions swap, and then you figure out which one's the precipitate. So sodium is originally with chloride, it'll now go with nitrate, so NaNO3. And then silver was originally with nitrate, it'll now go to chloride, so AgCl. Use your solubility rules that you learned in modules 5 as well as module 8. Of those two products, which one is the precipitate? Mm. Yep, it's the AgCl that's insoluble. The NaNO3 nitrates are always aqueous, group 1 is always aqueous. So remember, they're asking me for chlorine. All of the chlorine is in sodium chloride. So that's where I want to go. I want to go to the sodium chloride. So which means I should start with my silver nitrate. So moles of AgNO3 is C times V. 0.3540 molar, 22.79 mils. So 0.3540 molar times 0.000, yeah, 02279 liters. What do you get for the moles of silver nitrate, please?
0.008.
Thank you, 0.008 mole. That'll get me, now remember, I want the chlorine in compound A. All of the chlorine in compound A is turned into sodium chloride, so I need to get sodium chloride. I've already balanced the equation. It didn't need any extra balancing. So the moles of sodium chloride is the same as the moles of silver nitrate, AgNO3. 0.008 mole. Okay. Again, guys, the whole point of the question was to ask you for chlorine. They don't actually want sodium chloride. It's just that all of the chlorine converted into sodium chloride. Yeah. What that means is all of the chloride in sodium chloride came from compound A. Okay. So the reaction converted all of the chlorine in A into sodium chloride. What that means is all of the chlorine in sodium chloride came from compound A. So I need to figure out if it's 0.008 moles of sodium chloride, how many chlorines is that? What's the invisible subscript on the chlorine in NaCl? It's an invisible one. So therefore, if you have 0.008 moles of NaCl, it's also 0.08 moles of just a Cl from compound A. Okay? Cool. Not done yet. That's the total moles that came from compound A. That's not what they asked you. They didn't ask you that. Okay? They asked you, in a single molecule of compound A, how many chlorine atoms are there? Okay, guys, one molecule has discrete numbers of atoms. Yeah, I'm saying like 1, 2, 3, or 4. You can't have 0.008 of an atom. Yeah? So they're saying a single molecule, how many chlorines are in there? All right? Which has to do with ratios. Okay, guys, read the question again. Any numbers that I haven't used up? Part B.
The 100 mils.
100 mils of gaseous compound A. What else?
The 25 and 100.
I haven't used 25 degrees Celsius and the 100 kPa. Guys, you have now figured out all of the moles of chlorine that came from compound A. Yeah? For me to figure out how many chlorines are in an actual molecule, I want to know the ratio between compound A and the chlorines that it has. Yeah? If I want the ratios of compound A and the chlorines, ratios are done in terms of moles. I've got the moles of chlorine. I now need the moles of compound A. All right. They told me it's 100 mils of gaseous compound A in 25 degrees Celsius, 100 kPa. I'm going to use my PV as nRT to figure out the moles of compound A. Then I can figure out the ratio. Okay. So let's leave this for now. That's the moles of chlorine, but I need to know how many moles of compound A that came from. So PV is nRT. N of compound A is PV on RT. That's just me rearranging the equation. The pressure was 100 kPa. Guys, if you're going to use pressure in kPa, volume has to be in liters. Yeah, your two options are kPa with liters or PA with M3. You're not subbing in mils. Okay? If your pressure is in kPa, my volume is in liters. They told me it's 100 mils, so I'm going to sub it in as 0.1. Divided by ideal gas constant, we saw from the previous question, 8.314 joules per mole per Kelvin, times temperature is 25 degrees Celsius. You told me from the previous question as well to convert it to kelvins, add 273.15. Okay. How many moles of compound A did all of that chlorine come from?
0.004.
0.004.
It's approximate.
Approximate, yes. Oh, so in that case. All right, guys. You had 0.08 moles of chlorine total. That came from 0.004 moles of A. What is the simplified whole number ratio?
One to two.
1 to 2, okay? 0.004 to 0.08, that's already a ratio, but if I simplify it, it's a 1 to 2 ratio. What that means is a molecule of compound A contains 2 chlorine atoms, okay? One molecule of compound A contains 2 chlorine atoms. And that is your answer. Okay? Very good. All right. Part C. What is the molecular formula of compound A? Justify your answer. Molecular formula is how many atoms of different elements are in it. Yeah, you already know the amount of chlorines. Okay, so guys, in part B, you figured out, so from part B, you've already figured out that there's 2 chlorines. Okay, what did you figure out from part A? What was part A asking you about?
Molar mass.
Molar mass. Okay, so from part B, 2 chlorines, from part A, molar mass. And what was that molar mass from part A?
170.9.
170.9 grams per mole. Right? So guys, part C is asking you for the molecular formula, which is, I don't know, how many different elements are in it and how many of those elements there are. From part B, we already know that there's 2 chlorines. From part A, 170.9. However many elements there are, whatever the elements are, the combination of them has to add up to 170.9. True? Yeah, because you know the formula and then you multiply it all up to get the 170.9. That's how you normally do molar mass. Okay, so whatever this 170.9 is, it's 2 chlorines plus whatever the other elements are. And like I don't know how many there are, but they did tell me that compound A contains carbon, fluorine, and chlorine, right? I've already got 2 of the chlorines. I just need to figure out the carbon and the fluorine. Yeah? Okay, so this 170.9 is 2 chlorines plus the carbons plus the fluorines. Because I already know the chlorines, guys, I don't want to deal with it anymore. Okay, I only want to focus on my carbons and my fluorines now. I'm going to subtract the mass of the 2 chlorines from my 170.9 so I can just focus on my carbons and my fluorines. Yeah, so carbon with the fluorine with the 2 chlorines is 170.9. The carbons alone with the fluorine with no chlorine, 170.9 minus 2 times your 35.45. What is the mass left over just for the carbons and fluorines? 100. Okay. And then let's take a guess, yeah? So the carbons and the fluorines together is 100. There's two unknowns here. Okay? If there's two unknowns, normally from maths class, you guys need two equations to solve for it. Okay, we only have one. We only have the one number, 100. If you don't have enough uh if you don't have enough information to solve for things directly, you have to use trial and error. Okay? So the however many carbons there are, however many fluorines there are, those things add up to be 100. Let me trial number one. Let me do one carbon. Okay? The mass of a single carbon is 12.01. Yeah? So carbons plus the fluorines is 100. One carbon is 12. 100 minus 12.01 will give you the remaining mass for the fluorines. This is trial and error, okay? So 100 minus 12.01, what's the mass left over for the fluorines if, let's say, it is one carbon?
87.99.
87.99, okay? So, which is for the total number of fluorines, yeah? So if there's one carbon, everything adds up to 100. The remaining mass for the fluorines is 87.99. Okay? What's the mass of a single fluorine? One fluorine from your periodic table? 19. Okay. 87.99 is all of the fluorines added up. So guys, think about this, yeah? If there was two fluorines, you'd do 19 times 2, right? And then if there was three fluorines, you'd do 19 times 3. Yeah? So if I want to figure out the number of fluorines, I'll do the total divided by the 19. Yeah, so let me do 87.99 divided by 19. How many fluorines does that give you?
4.6.
4.6. Is it possible to have 4.6 fluorine atoms? No, okay? The number of fluorines is a total number. So therefore, one carbon and 4.6 fluorines, is that going to be our answer? No. Okay, so let's keep on going. We just finished one carbon. That one's not going to work. You can't get a non-whole number for fluorine atoms. It has to be a whole number. Number two, trial number two, let's say 2 carbons. Right, so the whole thing is 100. Let me subtract 2 carbons. So 100 minus 12.01 times 2. What's the remaining mass left over for the total fluorines?
75.98.
75.98. That's again the total fluorines. Let me divide by the mass of a single fluorine again to see how many fluorines this gives me.
It gives 3.9989. I think it should be rounded to
Yeah,
4.
3.9989, which is approximately 4. Okay, so is this one a more valid answer than the previous? Yes, okay, you can have 4 whole numbers of fluorines. So our answer at the moment kind of seems like 2 carbons, 4 fluorines, and the 2 chlorines we already figured out earlier. Yeah? Guys, we know what the molar mass is supposed to add up to. We calculated it in part A. Yeah, it was the 170.9. So it does round off very, very nicely to number 4. But if you're uncertain, you can calculate the molar mass of it and check. Yeah? So what did we say? 2 carbons, 4 fluorines, and then 2 chlorines. So just pop this in your calculator quickly. 2 times 12.01 plus 4 by 19 for your fluorine plus 2 by 35.45. Does this give you the 170.9 that you calculated from part A? Yes, it does. This should give you about 170.9. So therefore, this is your molecular formula. Okay? If you have two unknowns, you need two equations to solve for it. If you don't have enough equations, then it has to be a trial and error. That's your takeaway from this question. Okay? Good. All right. Well done. Part D. There is only one known isomer of compound A, which is compound B. No way. The two compounds have nearly identical boiling points, but can be distinguished by 19F NMR spectroscopy. It's not as hard as it seems. Okay, I swear to God. By analyzing when analyzed by this compound, compound A exhibits one unique chemical environment for fluorine, while compound B shows two distinct environments for its fluorine atoms. Draw the structural formulae for compounds A and B that are consistent with these observations. How many fluorines did we figure out from part C? 4, okay? Guys, compound A exhibits one unique chemical environment for fluorine. You have 4 fluorine atoms and they all have one chemical environment, which means all 4 fluorine atoms look the same and like what's around them looks the same. Yeah. How can you have a bunch of different atoms having the same chemical environment? What does that tell you about the structure starting with an S? The only way you can have a bunch of different chemicals have the same chemical environment is if it's symmetrical. Exactly. Okay, it has to be symmetrical. You can't have it otherwise. If it was asymmetrical, then the different fluorine atoms would have different environments, right? So D, compound A is the one that has the symmetry. So guys, you have 2 carbons. You have 4 fluorines to put on here. How would you put the 4 fluorines so that it's a symmetrical structure? 2 on each. Exactly. Okay, I'm going to put 2 fluorines here and I'm going to put 2 fluorines here. Yeah. And then you'll have the 2 chlorines left over to put in, and that'll give you your symmetrical structure. So this is compound A. If you're only going to have one chemical environment, the structure is symmetrical. Yeah. Compound B is asymmetrical. It shows 2 distinct fluorine environments. Okay. How are you going to place the fluorines on the carbons if it's not symmetrical this time? There's only one way you can do it. You can either do 2 and 2, or you can do 3 and 1. Exactly. 1, 2, 3, 1, and then the 2 chlorines go on the same. Yeah? So guys, NMR works the same way for all of the different elements. I know 19 fluorine is different, but it's just that if it's proton NMR, you look at the hydrogens. If it's carbon NMR, you look at the carbons. If it's fluorine NMR, you just look at the fluorines. Yeah, that's pretty much it. But the technique is still the same. Yeah?